So I'm going to go through and explain the scientists that were pivotal in discovering the atom and what we know so far about the atom. So the first person that I introduced in class was Dalton. Now Dalton doesn't contribute anything new to what we already know or what we've already talked about in our class so far about atoms, but it's important to note a couple of things he said. First of all, he said that atoms of a specific element are going to be identical. He also said that atoms can never be lost or gained. You can only change the orientation of them or break them apart or combine them together. And the last thing he said was that elements can combine together to form a specific compound. So this is a very broad view of atoms, and the reason why he didn't go more in depth about, the subatomic particles that we now know about is because he didn't have the technology to be able to do that. The first person to really discover subatomic particles who's given credit is Thomson. And so what Thomson did, he discovered the electron. Now, he didn't invent the electron. The electron already existed way before Dalton's time. I mean, it's what makes us who we are. But Thomson was the one who actually discovered it, and this is how he did it. He took a tube, and pardon my drawing, it kind of stinks. Okay. And he put positively charged plates on either side. And then he shot particles through the tube, not really knowing what they were, and discovered that the beam deflected. So it was it caused it to kind of curve upwards towards the positive sign. And so what he discovered was that these particles were negatively charged. Now, we know that positive attracts negative, and therefore what he discovered, and he knew that as well, he discovered that these negatively charged particles were part of what make up an atom. And so he called these negatively charged particles electrons. Now, he realized that atoms were made up of negative charges, and the reason why Dalton didn't discover these subatomic particles was because atoms have no charge. And so what Thomson went ahead and did was he said, okay, we've got an atom, it's got negative charged particles, therefore it has to have positively charged particles. So he assumed that all of an atom is positively charged throughout, okay, all of it, and then dispersed within the atom, the positively charged atom, you've got, kind of like chocolate chips, negatively charged particles. And he called those negatively charged particles electrons. And he called this model the plum pudding model. Now the reason why, because this is what plum pudding looks like now. This doesn't really mean a lot to us because we don't eat plum pudding, and so another name for this model, other than the plum pudding model, I call it the chocolate chip model because it looks like a chocolate chip. So the entire cookie is positively charged, and then you've got electrons as the chocolate chips kind of dispersed in it. Now, the next person to come along, the next subatomic particle to be discovered, is our proton. The person who did that actually did it by accident, and that's Rutherford. And what Rutherford did, he was actually the student of Thomson, and so he wanted to prove Thomson's model correct, and he accidentally proved it wrong. So we will give him credit for the proton, and then we'll also give him credit for the nucleus, because this is what he discovered. All right, so what Rutherford did was he took gold and he pounded it down into a really thin sheet of gold. And the reason why he used gold was because gold is malleable, extremely malleable, so he was able to make a super thin sheet of gold. And then he took alpha particles, which are positively charged particles, and he shot them through the foil. Now, if Thomson's model was correct, what should have happened is that the alpha particles, the positively charged particles, should have completely just shot through the foil. And the reason why is because there isn't really a concentrated positive charge. It's evenly distributed throughout. That's not what Rutherford found. Instead, while most of the particles shot completely through the foil like he expected, a couple did something really bizarre. They were deflected, they bounced off the foil and bounced backwards, or they were just kind of deflected like that. That wasn't expected. There was no reason why they should be deflected. There wasn't a concentrated positive charge, but there was. In an atom, there's a concentrated positive charge, which we call the nucleus. Now, what provides that positive charge to the nucleus are protons. So that's why we give Rutherford credit for protons and then also the nucleus. So within the nucleus, there are protons. Now I'll represent that with a P+. And then around the nucleus, you've got electrons orbiting around it. Now, we'll learn in the next unit that in fact electrons don't orbit, but for our intents and purposes, we'll say that they're orbiting around. And the interesting thing is that the majority of an atom, unlike what Thomson thought, which was that it's all positively charged, most of an atom is empty space because the nucleus takes up very little space. The electrons don't because they're just kind of moving around. Most of the space in an atom is positively charged. Now, if you were very vigilant when you were in, I don't know, maybe 6th grade, we've got only 2 of the 3 subatomic particles. We've got electrons, we've got protons, now we need neutrons. Chadwick was responsible for discovering neutrons. And the important thing for you to know about neutrons, number 1, they have no charge. And number 2, they're found in your nucleus. So now, thanks to Chadwick, we can add neutrons to the nucleus. Something important for you to know, when we're considering electrons, we never consider their mass. Instead, what contributes all of the mass of an atom are the protons and the neutrons. The interesting thing is that they are located in the nucleus and therefore take up very little space. So even though the nucleus takes up very little space, it contributes all of the mass of an atom. And that's it. So we've got Dalton starting out talking about atoms in general, not knowing about subatomic particles. We've got Thomson who discovered the electron. We've got Rutherford who discovered protons in the nucleus and this whole structure of the atom, which we now accept. And then Chadwick who discovered neutrons. And that's it.